Good morning, Sean. Good morning. You are definitely not late. I was a little bit late. I started a minute ago. Today I am going to prepare at least the component placement for another evaluation board, this time for a keyboard controller. It will be a demo board with like 25 buttons, a few LEDs, and quite smart controller over I2C. So yeah, another demo board, nothing special, no rocket science. But today I want to make a component layout, maybe to start the PCB layout. I don't know, probably next time, because I have only 1 hour before another meeting. So yeah, component placement looks real, PCB layout looks unreal for today, but maybe I will start, at least. Thank you. It's quite periodical or repeating patterns in there, but I like it as well. Hello, Rahul. Today is the second part of the design. The previous week I captured the schematic. So now the controller is like given, ADP 5587. So the schematic is, let's say, ready, and today I am going to place the components. I still don't know what pitch will be between the buttons in a horizontal axis or vertical axis. So I will play with it for a while and try to find let's say a correct distance between the buttons. The worst thing about the KiCad 9 is when you grab the component, and even if the grid is a lovely number, yeah, here is 0.5 millimeter, and I can't grab the component by its center. It always grabs like anywhere, yeah. Here is the center, you can see, here is the center, and I can't grab it, so it's somehow placed on a strange coordinate. So when I want to place it precisely on 0.5 millimeter grid, it's impossible until I remove the decimal numbers. So it's I think it's a bug in release 6.0.9.0.0 version. So I'm looking forward for the fixed bug fixing release, hopefully very soon, and I hope this will be corrected, because it's annoying. And despite the fact I like disabled the grab to the graphics option, it's still grab the component anywhere, and the center is not, like, never reachable. I don't know. What I'm doing now is I fixed the top left corner button and decided that the horizontal pitch will be 12 millimeters. So I used the top left button as a reference point, and now I am placing the other buttons relatively to the reference button, and I'm using the math function, the formula function of the fields in the windows for the like options, or the entries of numbers. So I'm using 12 as a pitch times 4 times 3 times 5. It helps me to place the buttons in a matrix, and it's one of the best tools is position relative to and position, like absolute positions. It's reachable, not here. Here, positioning tools, move exactly, it's the absolute movement, and position relative to, this is what I've used now. Now this is the second row, so I have to change the offset. The offset in Y will be 12, and in X will be 12 times 0 this time. The second from the left will be 12 times 1, and so on. And why 12 millimeters? I don't know. I tried the first row, and the 12 millimeters looks like a good dimension. Yeah, it's a evaluation board. It doesn't matter, but yeah, 12 looks good, and I love the 12 millimeters because the size of the button is 6, so it means it's twice as wide as the button is, so it plays. Yes, I should, but I haven't issued the ticket yet, and I am not sure if I will. I'm not a friend of the ticketing systems, and programmers always look strange to me and are angry when I reporting bugs in an appropriate way. It means the way they don't like, and I don't know the way they like. So instead of complaining, I learned how to live with that bug, and I hopefully looking forward for the bug fixing release. So I beg your pardon, but I will not issue the software related bug report because I don't want to be hated by some sanctuary programmers. You probably mean trace calculator. Yeah, I can recommend definitely the KiCad, the default KiCad calculator. Let me show you. Calculator tools, and here is the calculator. You can go here, track width, and set the target current, the allowed temperature rise, the length of the conductor, and it will give you some numbers. So even if the layer is or track is on the external layer or internal layer, it will show you the limits of the design. So yeah, I recommend this one. It's embedded in the KiCad and it works. So it will look like a small calculator. I can see that I should place some mounting holes for the bottom edge of the display, probably. Yeah. So I don't know the diameter, but probably 3 millimeter. Yeah, 3 millimeter. So 2 extra mounting holes. .2. And as you can see, I can use the position relative to even for graphics. So now I'm placing the mounting holes, and instead of like complex or difficult positioning to the center of the holes, I just set the offset 0, 0, select point, select this because the graphics is always grabbed, and place the hole. And see that the hole is positioned correctly in the footprint, but the footprint doesn't represent correctly the display. The 3D model is somehow moved. So yes, that's my life. Okay. So for this, I recommend to go to the select screen because the 3D preview window display the select screen and draw a circle. Okay. So a circle of 3 millimeters, position to the center of this. Is it there or not? Is it? I need another one, and the same for the second hole, not this point, this point. Okay, now I am going to check the 3D model. Yeah, it's completely offset. So, but hopefully, I hope that the 3D model of the display is correct because I didn't create it. I didn't create it. So it should be correct. And I will correct the footprint. Okay. I need to find the offset. So let's say this. No, the opposite direction. Now I'm in the orthographic projection with orthographic projection is enabled, I think, or disabled. Just to not to use perspective. I don't need perspective now, and I need to correct position of the mounting hole slightly. Yeah, this is good. Oh, this is good. And the circles will be aligned. Yeah, it can work. It can work. So now I need to know the distance from some reference point. Let's say reference point will be here. I need to be in the drawings from here to here, not there, here to here, 3.5, and here to here, 3.5. That's not correct. Don't make jokes. 2 millimeters. What's this?
Limited listening. Head over to brain.fm or follow the link in the description below.
Yeah, 2 millimeters. And the second hole will be 32.5. What about the other holes? Point 6. 64 is not very nice number. Yeah. So let's correct the footprint. So properties of the footprint, edit library footprint. Now I will help myself with the window placement. So let's say we have some reference point. So offset is 2 and 3.5 minus from the bottom left corner I need to place an object to that corner. Like this. Because otherwise I can't reference to the corner. Now I have an object there. Okay. The other one is 32.5. Okay. Now the same thing with the pad as before, but for the upper left corner. Yes, this will be 2.64. Okay, I hate this number, but okay. 2 millimeters and 1.64. No, I didn't select the point. Here. Okay, and the other one will be 32.5. Great. Remove the auxiliary pad. Perfect. Now I can update the footprint in the design from the library. Yeah, the holes are updated, and now I can place the mounting holes. So thank you for your patience, but I'm there. Good. Now it looks good. I don't need the upper holes because the fixation or the header will hold the display on the upper edge. So I need only two bottom holes. Two bottom holes. Okay. So the rest of the components is waiting for us. Yeah, this one. I will start with the headers because with the header, because I need to place it here. Somewhere here. The controller will be like here. I don't care. Like to look good, there will be some space for labels in between the buttons as well. I'm going to place the LEDs. I have 6 LEDs, so I think I will place 3 on the left edge of the display and 3 on the right edge, like in the symmetry, or 3 rows of 2. I don't know. Something like this. It doesn't matter. It's demo. So the LEDs are here. Yeah, it can be placed here with the nice space for labels on the right side. Could be good. The transistors for the LEDs are here. So here is the, yes, here are the components for the driver. So let's start with them, and the rest will be for the LEDs. The most important is the decoupling capacitor around, I will close the CD model, around the, or as close as possible to 21st pad. 21st is here. So let's say like this. There are 2 pull-ups for the I2C, 22 and 23. Okay, now this way. SDA and SCL. There are 2 resistors, like working resistors for the open drain output, the reset input and the interrupt output, open drain, both 10 kilo ohms. So somewhere near the pads. Yeah, so basically like this. This allows me to effectively connect the 3.3 levels. Yes. And the rest of the components will be for the LEDs. So first LED, this one, I will place it under the display to keep the design clean, because I don't suspect any troubleshooting with the LED drivers. So I can't afford to have the driver below the display, because yeah, I can live with the fact that the components will be hidden. Something like this. There's no space for cat. That's bad. Oh, like this. Why not? Okay. So I will prepare the board setup for the PCB layout, but I will start the PCB layout next time, not today, because I have an appointment at like 3 p.m. of my time in 13 minutes, so I will not start today, but I will prepare everything for the next week. Board finish will be 𝗏𝗍. I will manufacture at 𝗏𝘁𝗍𝗏, so the 𝗏𝗍𝗏 is the standard finish for the beautiful boards, as they call it. Defaults, I can keep the defaults as are. Constraints. Via diameter will be, I think I will go with 0.603 because this design is not something sensitive or dense. As you can see, the board is huge, and there will be like 5 tracks, not 5, but very few. So I can keep it as is. I will like to use 0.5, maybe 1.0. Teardrops I will keep by default. Clearance is okay. Default will be 0.25. I will keep 0.2. Via size is 0.6, 0.3. It's okay. Custom rules nothing. Severity nothing. Embed fast nothing. Okay, so the board is ready to be routed, and maybe I'll try to route, or at least to see how the buttons will be connected. So these are the column pads. Yes. Yeah, and as you can see, it plays because the left column goes to the most left pad on the IC, and the right one, the right column goes to the most right one. So it means that the tracks will not cross each other. So it means that I did a good job at schematic capture. Okay. And the rows, this is the second pad from the left on the bottom. This is the most left bottom pad, so these tracks will cross each other. So I should no, I can go from the right side. What's better for me? Yeah, I will keep it. I will use the bottom layer to connect the rows, and the top layer to connect the row to the IC, as well as for columns. And the tracks can be long because there is no sensitivity for anything. So I can go from there, from the bottom up. Okay, it will go, it will work. And yeah, nothing special I see here. Probably the pinout of the header, it can be changed. CL SDA, reset, interrupt. I will keep it, nothing wrong with it. Yeah, it will be easy to connect. Yeah, the board is huge, and as you can see, it's plenty of space for anything and everything. Okay, so I think I'm done for today. Thank you for watching. Thank you for your questions. I will continue next week. I will allocate more time, probably on, let me see, probably on Wednesday afternoon. Like, I will allocate 2 hours, and we will see how it will work and what will be done. So thank you again, and have a nice rest of the week. Bye bye.